Hi, welcome to another episode of Tom Kennedy Science, and I'm your host, Dr. Tom Kennedy. You may be thinking he looks a little different today. Did I lose weight? No. I had to shave my beard down a little bit, but I kept the mustache at least for a day. I think it's quite epic. It's all gray, of course, so it doesn't really stand out, but I'm going to enjoy it for the next day or so, at least until I'm forced to shave it off. But today, I want to talk about something that is kind of profound, actually. I know lots of things are profound, but science is profound. And how we do science, how we science, which is the scientific method, has shown us a lot about the world. And in fact, scientific discoveries have revolutionized the way that we understand the world. And not only that, it's also like revolutionized the way we see ourselves as part of the world and how we see the universe and our place in the universe as well. So, I want to ask you a question. And that question is, what are the most important scientific discoveries, theories, laws, observations that you can think of? Which are the most important ones that have really changed the way that we think about the world or the way we see ourselves as part of this universe? I think about this a lot, right? I mean, I teach science, so I often think about, some of the greatest discoveries of all times. The reason why that I ask this question is because scientific revolutions, they change how we perceive the universe. And it's changed quite a bit, We no longer think that we're the center of the universe. We no longer think that the universe revolves around humankind. And we've known this for a while. And this is important, right? Because observations, discovering facts, these also leads to theories. And this leads to a deeper understanding of the way the universe works. So, some of these discoveries are just absolutely revolutionary. I mean, think about this. The world is round. Wow. I know, in our world today, we take that for granted. Humans haven't always known that the world is round. And not only is the world round, it's actually quite small. This image here was taken by the Voyager spacecraft, and it's of the Earth. Well, Carl Sagan, who I've talked about before, he said, we need to get an image of the Earth from the edge of our solar system. So he had the Voyager spacecraft turn around and take this image. And that pale blue dot caught in a sunbeam, caught in a ray of light, that's us. That is our home. And I want you to think about that. That speck of dust is us floating in the cosmos. Every war that's ever been fought, every person that's ever fallen in love, every biology test that's been aced has occurred on the pale blue dot. That's our home. That's us. We are not anywhere else in the universe. So we are not the center of the universe. And in fact, we occupy a very insignificant part of it. But yet, humans are not insignificant. You will search the universe over, and I doubt you will find you or me or anything exactly like us. And Copernicus, he was the one that came up with heliocentrism. And he figured out that the Earth was not the center of the universe by studying the orbits of the planets or the tracks of the planets as they go across the night sky, the sun and the moon. And he realized that the sun is at the center of our solar system, not the Earth. That was a pretty big revolution. He was afraid to publish his data, right? So that was pretty big. And a little while longer, Newton came along. And Newton was a huge intellectual step in human understanding of the natural world because he was the first person to realize that the laws of nature, like motion and gravity, can be written down mathematically. And he, of course, came up with Principia, and he developed the whole field called calculus. Ironically, we don't use his notations for calculus, but he invented a new form of math just to understand the orbits of the planets. So he was revolutionary in our understanding of the world. And then in the early 1900s, this patent clerk, named Albert Einstein revolutionized the world with his simplistic equation E equals mc squared. Energy is equivalent to the mass of an object times the speed of light squared. That's a lot, right? The speed of light is like 186,282 miles per second. You could go around the earth 7.5 times in 1 second. That's how fast the speed of light is. And you square that and then multiply it by the mass of an object, and that's the energy tied up in the mass of objects. And Einstein realized there was enormous amounts of energy tied up in the mass of objects. And this is the energy matter relevancy here. And this is a huge leap forward. I mean, this ushered in the atomic age. They realized that there was lots of energy tied up in the mass of objects. So whenever we blew up our biggest atom bombs, whenever we blew up our biggest atomic weapons, about 1 gram of matter was converted to pure energy. That's pretty crazy, isn't it? And of course, this put a universal speed on how fast you can go, because you can't go faster than the speed of light, because as you go faster and faster and faster, it takes more and more energy. You know this. It's easy to walk a mile. Go jog a mile, takes more energy. Sprint a mile, takes even more energy. If you don't run or sprint, you've probably driven a car, right? The faster you go, yeah, you get there quicker, you use more energy. So as you approach the speed of light, the mass of an object approaches infinity, which means it takes an infinite amount of energy to push an object of mass beyond the speed of light. Amazing, right? I mean, that's an incredible revolution in our understanding of the world. Einstein once again revolutionized the world 10 years later with his general theory of relativity. This was a theory of gravity. No, wait, I mentioned Newton's law of gravity. Newton's law of gravity is an object will fall at 9.8 meters per second squared. It's a law. It tells you what's going to happen. It doesn't tell you why or how it happens. Einstein, in his general theory of relativity, published in 1915, was one of the biggest intellectual steps forward by a single human probably in the history of the world, because Einstein realized that objects of mass, that matter, warp space-time. And I mean, it took Einstein like 2 years to figure out the math behind this. I mean, amazing. And he did not get a Nobel Prize for either theory of relativity. He actually got it for the photovoltaic effect, which we use it today. It's how you can convert sunlight into electricity using solar panels. So Einstein was indeed an amazing human being. There are other revolutions in science as well. One of them is quantum mechanics. This was done by a number of people that figured out how the universe operates at the scale of atoms. And that is odd. I mean, you can have electrons in two places at once. They move as waves, but then they can be a particle. They can have entanglement where they can instantaneously affect each other over long distances. And it's indeed our theory of quantum mechanics that makes your computer possible. It makes our cell phones possible. It makes Laserdisc possible. Much of our modern day electronic technology is based on our understanding of quantum physics. And we still haven't figured out exactly how quantum physics works because we haven't reconciled it with the general theory of relativity. I know, so we still have some stuff to do here. But there is another theory out there that really revolutionized the way not only we see our place in the universe, but also revolutionized the way that we do science and the way we think about the natural world. And of course, this theory is evolution by natural selection. Now remember, evolution is a fact that species change over time. I can observe it. I can measure it. I can verify this through experimentation as well. We can see species change over time. But natural selection is a theory that explains why species change over time. It's part of it is survival of the fittest, and I've got another videos on this. But this theory changed the way that we think about science. So it's not just important for biology, it's important for all science as well. And evolution by natural selection is so important not just to all science, but it's also biology's central paradigm. It's the entire theory that we built biology around, this idea that species are changing over time due to these natural processes. And that means that we're all related to each other. We descended from common ancestry. And that's why we have so many things in common with other species. So, I always ask people, what do they know about evolution? Is it not true? Maybe true? Is it a valid scientific theory? Is it a fact? And a lot of people say, well, it's just a theory. We weren't there. But remember, a theory is explaining how things work. And not only does natural selection, evolutionary theory, explain how things change over time, this theory is so important because it explains the unity and diversity of life. One theory does this, and this is important, right? We know that evolution is both a fact and a theory. Species change over time. Fact. We evolved from a lobe-finned fish. How we did that? We can actually see the changes that take place over time. And in fact, my arm right here, let me see that here. My arm is a modified fish fin. I know it sounds weird, but it is. And in fact, we know this based on development. We know this based on the fossil record. And even the history of our species is carried in our own DNA, which is amazing. So look at this picture right here. Central paradigm. These are all vertebrates. Animals with a backbone. I've got a fish. I've got a salamander. I've got a lizard, and I've got a squirrel. Do you notice any similarities? They all have a backbone, right? We got a head with a mouth. We got a digestive tract. We got heart. We got a closed circulatory system. We have muscles coordinated by a nervous system, right? And so we share all of these features in common. Why? Well, we share common ancestry, right? Look at this. I've got a human arm. I think that's actually a cat paw. And a bird wing and a whale fin. They have the same bones. One bone. Two bone, lots of bones. Why is that? Common ancestry. We came from an ancestor that had one bone, two bone, lots of bones. Think about your leg. It's the same way. This is why it's a paradigm, right? Because it can put any biological observation that I might find into context, right? And that's important. So we also know that while there's unity in life, one bone, two bone, lots of bones, and all tetrapods. Tetra means four, pod means foot. So all amphibians, reptiles, mammals, and birds, right? We are that four-limbed. But that group has 30,000 species. There are 2 million species of animals. There are millions of species of life on this planet. And yet we all share things in common despite this great diversity of life, whether it's a primitive moss, a scallop, or this beetle. Right? So unity and diversity of life, that's our central paradigm. Okay. Now, importantly, I said when I started this off that scientific theories and observations change the way we think about the world. It changes our perception of our place in the universe. And I showed you a pale blue dot showing, that the Earth is indeed occupies a very tiny place in the universe. So evolution by natural selection, not only does it explain the unity and diversity of life, because we can, every time we find a new species, I can categorize it based on a similarity to other species. But here's the other thing why evolution by natural selection was so important. And the reason why is up until Darwin's time, most of your scientists were these gentlemen naturalists, and they were collectors. And at the time, nobody really understood how species changed over time. Nobody understood the origins of life. Nobody understood why there's so much diversity. And a lot of the ideas of how that happened was, well, some divine creation made that back in the past. And this idea of like every form is created perfect and any deviation from perfection, which would be the antithesis, which would be the opposite of natural selection, came from the Greeks, Aristotle. Once again, Aristotle kind of, affecting Western culture and not necessarily in good ways either, right? But he had this idea that there was this great chain of being where there were lower and higher forms, but everything was created at some point in the past in this perfect form. And that was, people kind of just accepted that. And then Darwin comes along and he proposes a theory that you can go out and test. You can make additional observations on. And what that theory did is said, you know what? We don't need a supernatural explanation to explain the origins of life or to explain how we have so many species on this planet. We can use a natural explanation. We can rely on the natural world. And Darwin's explanation for why there are so many species over time, why they share similarities, that unity and diversity of life, and proposing natural selection as a mechanism of evolution, that started to really change everything about science. No longer did we rely on any type of supernatural or divine explanation to explain our universe. We could use it through science. And, Darwin published in 1859, and he had been collecting data since the 1830s on evolution by natural selection. Here we are in 2021. Wow, how long has that been? It's over 160 years or more. We have yet to find evidence to overturn the theory of evolution by natural selection. Now, we can see that populations might evolve by other mechanisms other than natural selection, but they're still evolving, and natural selection is by far the most important driving force causing species to change. So his theory said, you know what, we no longer need a vitalism. We no longer need divine creation or anything like that. That is the role of science in changing the way that we perceive ourselves in the universe. Okay, I don't know about you, but I like trying to figure out how the world works, right? And sometimes we honestly don't know everything. What were the conditions that led to the origins of life on this planet? We're figuring it out. Just because it's hard doesn't mean that we throw our arms up and say, oh, we don't know how to do that. We continue to find those answers. In the last couple decades, we've actually made huge strides in discovering the conditions that may have led to the first life on this planet. Where did the universe come from? The Big Bang. Well, where did that come from? You know what? That's a hard question. There's not a lot of evidence left from the origins of the universe that happened 13.8 billion years ago, but there's still evidence out there that the Big Bang happened. There's still evidence that we had an origin to our universe, and scientists don't stop asking those questions, even though they're hard. We might discover in the next 5 years what caused the Big Bang. We might discover in the next 100 years. The origins of the Big Bang might actually be unknowable because the information that would allow us to understand how it happened might be gone. But that does not mean you stop. Okay, so doing science, scientific revolutions are very, very important. Well, this has been another episode of Tom Kennedy's Science. I'll see you next time.